It's just booting up now. Okay, we're back. We're back on YouTube, and I'll try and keep the level down a bit because I think that's all it really was. I was speaking a bit too loud into the microphone. Now, as far as I know, Discord should be there. Yes, it is. Okay, so the Discord video stream has all arced up all on its own. Steve VK3SPX reports minimal delay is great on Discord, but the resolution not as good as YouTube, at least at my QTH. Yeah, well, I don't know. It looks pretty good here. No, I won't go mucking around with it right now, or else I'll do something horrible. So there it is. Anyway, we have Dave VK3KDM also on the chat room, and also Steve VK3SPX. So all very good. Okay, now back to the sky notes. We're coming up to the winter solstice. Winter solstice occurs this month in the southern hemisphere on the 21st. The sun rises and sets at its most northerly points. Its path is at the lowest of the year, giving us the shortest day. Its rays arrive at the shallowest angle, giving us at least the least energy per square meter. And then there's a few reports on the recent aurora activity. Across media and online last month, beautiful pictures appeared of the aurora australis, or southern lights. So we appeared this brief explainer about the extraordinary phenomenon enjoyed by so many, including the metropolitan Melbourne, as seen below. So yes, I've got a couple of pictures here of the aurora that was pictured from the bay, Port Phillip Bay. It's not a very strong aurora, as you can see there in the pictures, but nevertheless it was seen by quite a few. This is from space, how the aurora basically encompasses the Antarctica and the South Pole in general, captured by remote satellite imaging. And this particular aurora was photographed from our dark sky site up at Heathcote. So as you can see in the foreground is the dish antenna. This is the 8.5 fully steerable dish antenna that I mentioned before. So that's the radio astronomy dish, and that's the aurora photographed from Heathcote in central Victoria. Out of interest, there's a little chart here I'll show too, which is interesting. This shows you basically, because the aurora generally has lots of colour associated with it in some cases. This particular chart here shows what's going on at certain heights above the Earth, and excited atomic oxygen at high altitudes, excited atomic oxygen at lower altitudes, and ionized molecular nitrogen at distances of up to 100 kilometers above the ground, above the surface. But generally the color of the aurora can be seen, and by telltale signs of various excited elements. So yeah, very interesting to be able to see the full color stream that you can get from the aurora. So really is quite good. I hope one day to be able to see the full colour that's capable from this sorts of activity. Moving along very quickly, I want to keep a pace going. All right, they're saying here that space weather includes the effect our local star, the Sun, has on Earth. In the current solar maximum period in the Sun's 11-year cycle of energy output, increased solar activity has generated higher than normal levels of solar particles in the solar wind that blows out across the solar system in all directions. This current solar max is occurring a year earlier than predicted and is creating auroras further from the polar regions where they normally would appear. As our planet rotates its solid iron nickel inner core and liquid iron core outer core act as a massive dynamo, generating electric currents, which produces an extended protective magnetic field enveloping Earth. Physics has shown that an electrical current in a conducting material, whether it be copper wire or an entire planet, will produce a magnetic field. The reverse is also true. A magnetic field can induce an electric current, and such is the dual nature of electromagnetism. Earth's dynamic field deflects most of the high-energy charged particles of protons and electrons that form from the solar wind, and which travels at 400 to 800 kilometers per second. Some particles, however, spiral in between field lines and are trapped over our planet's magnetic poles. In a process not fully understood, billions are released and collide with air molecules in the upper atmosphere. And here's another drawing of that. Where are we with that? It's down here somewhere. Didn't I bring that across? Maybe I didn't. Okay, I thought I did. I won't worry about it. I did show it last week anyway. All right. Anyway, so as a result, you get colourful curtains. These particles impact energy to high-altitude air molecules, which become temporarily charged and then release protons of light as specific wavelengths, corresponding to the aurora colours we see. Excuse me, as they return to their normal unexcited state. With Earth's magnetic field lines constantly fluctuating, the overall effect is shifting patterns of colour in the upper atmosphere, looking very often like vast curtains rippling in a gentle breeze. Auroras typically occur at between 100 to 300 kilometres altitude, and sometimes as high as 600 kilometres. Colours are green from oxygen, pink from nitrogen, red from higher altitude oxygen, and blue or purple from hydrogen and helium, although these last two are not easily seen. The auroras occur at all times, but are best seen on clear nights where they can be quite a spectacular sight. So that little image on the screen right now is a good guide as to what's happening. Being solar maximum, it is highly likely that there will be more good times to observe and photograph auroras. The Australian Bureau of Meteorology's Space Weather Forecasting Centre advises on cloud cover, auroral conditions and solar wind activity, along with useful videos as well. Okay, now, yep, all right, just a few emails there I've just noticed. Okay, hang on a sec. Let me go back to camera. There we are. All right. Now, sun times. It is the 7th of June. So we'll go from Sunday. From the 11th of June, Sunday the 11th of June, the sun will be rising at 7:32 a.m., setting at 5:07. Wednesday the 21st, sunrise will be at 7:35, setting at 5:08. And by the end of the month, Friday the 30th, the sun will be rising at 7:36, setting at 5:11 p.m. Moon phases. There will be a new moon has already come and gone. Last night there was a new moon. On Friday the 14th, there'll be a first quarter. And on Saturday, the 22nd, there'll be a full moon. And by the end of the month, on Saturday, the 29th, it'll be a third quarter phase. The moon will be closest to the Earth on Thursday, the 27th, at 369,000 kilometres. And then it'll be furthest from the Earth on Friday, the 14th, at 404,000 kilometres, swinging about. Planets. Mercury. After its passage behind the Sun, it is not visible this month, being still too close to the Sun. Venus is not yet visible after having just completed its superior solar conjunction and passage behind the Sun. Mars can be seen in the early morning, rising in the east around 3:30 a.m, moving to the northeast before fading from view by dawn. Jupiter rises around 6 a.m. early in the month and a little earlier each month before quickly fading in the early dawn light. Saturn rises by 1 a.m. early in the morning and moves across the northeastern and northern sky before fading by dawn light. Mid-June, it will rise at half past midnight and by the end of the month by 11:30 p.m. Meteors. There are two minor meteor showers this month. The Aretid meteor shower, which is focused on the constellation of constellation of Aries, occurs through to June 24, but peaks on June 11. From Melbourne, the shower is likely best seen just before dawn, although low in number, less than 10 per hour. They can often be spectacular and bright, and many displaying a yellow-orange colour. The Booted meteor shower in the constellation of the Booties appears late in June and early July. The best time to see meteors is after midnight, with no moon in the night sky. Stars and constellations. Now, this is where the text on the website here has been corrected. So I shall read this out now. Stars and constellations. If we view to the west, if we all turn our chairs and look west, although Orion has disappeared below the western horizon, but has two dogs, Canis Major with star Sirius low in the west, and Canis Minor with the star Procyon low in the northwest, are still both in our skies. In the north, Leo, the lion, is still visible in the northwest with the bright star Regulus. Look for a large hook of stars or inverted question mark to locate the curving mane of the shoulders of the Leo, the lion constellation. Easy to see once you see that little upturned question mark. Turning to the east, Scorpius is in the southeast this month with the red giant star Antares as the middle of the three stars that form the Scorpion's body. During winter, the Centaur arches Sagittarius suits below the Scorpion and its bow and arrow, the famous teapot asterism. Then if we look towards the south, high in the southeast is Crux, or the Southern Cross, with the pointers Alpha and Beta Centauri. The text suddenly goes a bit funny here for some reason. The Southern Cross with the pointers Alpha and Beta Centauri lower down. In dark skies, two neighbouring galaxies and the large and small clouds of Magellan can be seen as small isolated patches in the southwest. From our southern latitude, they are easily seen every night. They don't set, actually, those two sister galaxies. In dark constellations, in dark locations, the broad band of Milky Way, billions of stars and numerous interstellar dust clouds stretch across the sky, which from the horizon to horizon, while some foreground stars in our local region of the galaxy can be seen. The large dust clouds obscure our view further into the galaxy, since our eyes and optical telescopes see only the visible part of the spectrum. Now, if you want information on when to see the International Space Station, best to go to a website called heavensabove.com. It's actually heavens-above, but just type in heavensabove.com and you'll be taken to the website. You can use the website as is, but if you want an accurate location information, for your location, that is to say what's happening in the sky, you'll have to type in the location where you are in latitude and longitude or nearest city, and that'll then update the screen to more reflect your location. So so the accuracy of the passes like the International Space Station and anything else for that matter will be more accurate to your location. But the Heavens Above website is a pretty good site for information about what's happening in orbit for many things, really. Amateur satellites as well as other satellites and celestial objects, of course. You're tuned to ASV Radio, VK3EKH, the official station of the Astronomical Society of Victoria, with a regular Friday broadcast. Now, I shan't worry about on this day. I'm just going to leave that until perhaps next week. All right. Now, just out of interest, if you're wanting to know what a lunar day is, I bring this up just briefly because last week in the WIA news bulletin, they talked about... was it in the news bulletin or was it the Old Timers Club? I think it might have been actually the Radio Amateurs Old Timers news bulletin. I think it was. They were talking about forming a lunar time standard because we're all heading back to the moon, and they figure that it's probably a good idea that some reference be made to how to keep a time standard on the moon. Anyway, there was a few questions asked. The lunar day. What is a lunar day, if you ever wondered about that? Now, I've got an interesting little graphic that's running here. Let me see if I can bring that up while we're talking this for a moment. There we go, a pulsating moon. All right. A lunar day is the time it takes for Earth's moon to complete on its axis one synodic rotation, meaning with respect to the sun. The lunar day is therefore the time of a full lunar day-night cycle. Due to the tidal locking, this equals the time that the moon takes to complete one synodic orbit around Earth, a synodic lunar month, in other words, returning to the same lunar phase. The synodic period is about 29 and a half Earth days, which is about 2.2 days longer than its sidereal period. Relative to the fixed stars on the celestial sphere, the moon takes 27 Earth days, 7 hours and 43 minutes and 12 seconds to complete one orbit. However, since the Earth-Moon system advances around the Sun at the same time, the moon must travel farther to return to the same phase. On average, this synodic period lasts 29 days, 12 hours, 24 minutes, 3 seconds, the length of a lunar month on Earth. The exact length varies over time because the speed of the Earth-Moon system around the Sun varies slightly during a year due to the eccentricity of its elliptical orbit, variances in orbital velocity, and a number of other periodic and evolving variations about its observed relative and mean values, which are influenced by the gravitational perturbations of the Sun and other bodies in the solar system. As a result, daylight at a given point on the moon lasts approximately 2 weeks from beginning to end, followed by approximately 2 weeks of lunar night. And as you can see there, how the moon waxes and wanes and oscillates just ever so slightly as it revolves around the Earth. So, yes, most fascinating indeed, our dear old moon. And of course, it's moving away from the Earth at about 3 centimetres a year, I think, is the average distance it makes. All right. You're tuned to ASV Radio, VK3EKH. Let me go back to camera. Actually, this is my other camera, which is revealing my horrible wall in the back there, which I've got to work on at some point in time. Now, we all know that SpaceX Starship made a successful flight today. The craft took damage as it re-entered the atmosphere, but survived to stick a soft water landing in the Indian Ocean. And we have a picture here of this rocket taking off. Let me see, where are we with this? Taken from a drone. It's a really great image. Quite stunning, really. Okay. SpaceX Starship upper stage survived the fires of re-entry to make a first ever successful controlled landing, splashing down in the Indian Ocean this morning, June 6, but not without drama, suffering damage to one of its flaps and its heat shield. Cameras on the ship's exterior clearly captured the growing damage during re-entry as the heat and pressure began to eat away at one of the large flaps that controls Starship's descent. The gasps and shouts of SpaceX employees could be heard on the company's broadcast as glowing chunks of debris flew off the flap, exposing skeletal mounting joints below. And there's kind of an image here too of that, if you can make out what's going on. There we go. There it is. And what you're seeing here is there's a hot spot that forms near the base of one of the Starship's flaps, and so there was certainly a certain amount of burning going on. Minutes later, the gasps turned into a deafening cheer as telemetry indicated that Starship had survived to reignite its engines for landing, the first time it had reached that point on a test flight. It didn't explode. The splash of the ocean water as the craft touched down could just barely be seen on camera, whose lenses had by now been nearly completely obscured by debris. The flight, which lifted off today in June 6 at 8:50 a.m. In Texas, was the fourth test flight of the Starship overall. The first three flights had ended with the Starship upper stage destroyed. This is the part of the launch system that will eventually ferry astronauts to orbit and land Artemis crews on the surface of the Moon and in SpaceX's plans, but also put humans on Mars. The furthest upper stage had gotten. Americans love the word "gotten." The furthest the upper stage had gotten was in its third test flight, where it reached orbital velocity, but lost control and broke up during re-entry on that flight. The reusable lower stage, the Super Heavy booster, also failed in its attempts to make a last landing in the Gulf of Mexico. Today, SpaceX succeeded on both counts. Not only did Starship reach orbital velocity on its way to the Indian Ocean splashdown, the Super Heavy booster made its first ever controlled splashdown in the Gulf, simulating a landing back at its launch tower. The twin successes mark a major milestone for the company in its goal to make Starship a fully reusable launch system. All right, we'll leave it at that. So they obviously had a fairly successful launch today. It's a massive rocket, and lots of money being poured into this project. So I don't know whether I'd be wanting to take a trip on that into space. I think they've got a long way to go before they get that very, very safe. This is VK3EKH ASV radio. Okay. Now, anybody who understands photography, exposure, and all those sorts of settings will find this next article, of course, type of thinking. But this is published on astronomy.com today, so I thought it only goes for a couple of minutes. Why do pictures of Earth taken from the moon show a black sky with no stars? I mean, like I say, anybody who's into photography or knows anything about exposure will know exactly the reason for that. It's no mystery, but there are a lot of people out there that think that we never went to the moon, and they think that why, in a lot of these shots of outside in space, there's no stars, so you can't explain it to them. There's a picture here of this. Where are we? Where's this picture? Come on. Where are we? All right. Now, I don't know why I didn't bring that across, but I'm going to do it. Just let me muck around with vMix for a second and bring up these pictures that I did have. This one and the one from the moon. This is a picture from the surface of the moon. I don't know why I didn't bring that across. Where is our astronaut? There it is. Buzz Aldrin. Okay. So here's a classic shot that I think we've all seen. Come on. All right. Now, that image on the screen right now. YouTube is running and Discord is running, as well as the repeater. So you see the moon in the foreground and the Earthrise in the background, but there's no stars. It's just a black screen, of course. We all know why. Let me read the article. Why do pictures of Earth taken from the moon show a black sky with no stars? Can the stars only be seen with an atmosphere, is the question being asked by Faris Bruce in California. The simple answer to your question is the camera settings used to take most photos from the moon weren't designed to capture stars. Apollo astronauts used film cameras, so to understand the answer, we need to explain a little about how camera exposure works. Film is a light-sensitive emulsion over plastic. When that plastic is exposed to light through the camera's lens, a chemical change produces a negative image of whatever is photographed. But the amount of light isn't always the same. A photographer has to consider the lens aperture and shutter speed, both of which control how much light hits the film. A small aperture means less light, as does a faster shutter speed. It's almost like how your pupil constricts on a bright day and dilates at night. Your eye automatically adjusts your aperture so that you can see in different conditions. A photographer also has to consider the most important part of a photograph before setting aperture and shutter speed. Generally speaking, the brighter the target object, the smaller the aperture and faster the shutter. Otherwise, too much light will hit the film and the photo will be dominated by a washed out, overexposed focal point. And now we go to this other picture that I've got here of the astronaut on the moon. This is Neil Armstrong, actually, I think. Okay. Continuing on with the article. Let's say you are Neil Armstrong photographing Buzz Aldrin during a bright lunar day. Buzz, in his spacesuit, and the lunar surface are going to be the brightest objects in your shot. So for him to be visible, you want to choose a fast shutter speed and a smaller aperture. The result is a clear image of Buzz, but other light sources like the stars are too dim to leave an impression on the film. Because the most important things the astronauts photographed were each other and the moon's surface, their cameras were set to capture them in focus, not the dimmer, distant stars. But there are some images where you can see stars in space. Apollo astronauts left the camera's shutter open longer during some photographic experiments, and the results show pinpoints of light beyond the bright, fuzzy blobs that are overexposed moon or Earth. So, I think that was an interesting little read, short and sweet. But yeah, a lot of people don't quite understand exposure. And of course, the digital cameras these days all do it slightly differently. But the same considerations have to be considered for exposure and sensitivity settings and whatnot. This is VK3EKH. All right. And now I'm going to make this a quick article too. Courtesy of space.com. The first telescope removed from controversial astronomy hub on Hawaiian volcano. This is something that's been going on for a little while now. The decommissioning of the telescope has seen the site reverted back to its natural condition. A 3-year survey will now watch how wildlife returns to that part of the mountain. And we've got a picture here of this on Hawaii. There it is. Okay. For the first time, a telescope on the Hawaiian volcano of Mauna Kea has been fully decommissioned. It was dismantled, removed, and its site was restored to previous conditions. The effort comes under an agreement between the University of Hawaii and the Mauna Kea, I'm not pronouncing that right, Mauna Kea Stewardship and Oversight Authority, designed to smooth tensions over the construction of a new telescope on the mountain, which is the 30-metre telescope. Since the 1960s, 13 telescopes have been built on Mauna Kea, a place that's sacred to the indigenous people of Hawaiian Islands because it is where the earth meets the sky. As such, each new Mauna Kea observatory has been met with dismay by protesters who believe the building of new telescopes on this volcanic mountain is sacrilegious. The astronomical community, however, has struggled to find a balance between their scientific research plans and the needs of indigenous Hawaiian culture. That's because the Mauna Kea offer uniquely pristine sky-watching conditions. Things reached a head with protests against the planned 30-metre telescope, TMT, which, if constructed, would be the second largest telescope in the world and the largest on Hawaii. However, questions mark still hang over the future of the TMT. The National Science Foundation has said it can only provide funding for one of either the TMT or the Giant Magellan Telescope, which is planned for construction in Chile. A panel was convened to determine which project the NSF should help fund. The losing observatory may still be able to go ahead should it acquire enough private funding, but the fate of the 30-metre telescope on Mauna Kea remains far from certain. Now, there's more to that article, but I will show just a couple of before and after pictures. This is the observatory in question that they want to remove, and a few other things in that general location. And there's a kind of a bit of a before and after here. You can see the observatory being decommissioned, being pulled apart by a crane, and of course on the right side, ultimately it finally being removed. And I think in this image here is where it's finally been graded and flattened out and completely restored back to how it was. So there it is. That's where we're having to keep in mind the indigenous people. and their requests, such as the way things go. You're tuned to ASV Radio, VK3EKH. All right, and keeping an eye on my time here. Now, this is interesting. This next discussion is really something that's been in science fiction for quite a while. There's a couple of books called Mars, which is a novel. Stanley Robinson, Kim Robinson, something Robinson is the author, and of course in his book he talks about an elevator, a space elevator that connects directly to the Earth and creates this huge tethering cord that runs out into space. Whether we'll ever have the technology for that is another thing, but anyway, apparently there's a Japanese company plans to build a tower into space by 2050. 2050. There's a little graphic here, a little artist's impression of this thing, and I'll just bring that up right now. It's not totally clear, but it'll do. Okay. Imagine a long tether linking Earth to space that could launch us to orbit at a fraction of the cost and slingshot us to other worlds at record speed. That's the basic idea behind a space elevator. Instead of taking 6 to 8 months to reach Mars, scientists have estimated a space elevator could get us there in 3 to 4 months, or even quicker, as 40 days. The concept of space elevators isn't new, but engineering such a structure would be no easy feat, and many other issues besides technology stand in the way. That's why the ambition to seriously build one is fairly recent. The Japan-based company, Obayashi Corporation, Japanese, thinks it has the expertise. Obayashi, I think that's how you pronounce that. Obayashi, if I say it slowly. Known for constructing the world's tallest tower, the Tokyo Skytree, Obayashi Corporation announced in 2012 that it would reach even loftier heights with its own space elevator. In a report that same year, the company said it would begin construction on the $100 billion US project, $100 billion US project by 2025, and could start operations as early as 2050. We checked in with Yogi Ishikawa, who wrote the report and is part of the company's future technology creation department, to see how the project is progressing around of 2025. While Ishikawa said that the company likely won't start constructing next year, it is currently engaged in research and development, rough design, partnership building and promotion. Some have doubted such a structure is even possible. It's been sort of a kooky idea, said Christian Johnson, who published a report on space elevators last year in the peer-reviewed Journal of Science Policy and Governance. They said there are some people who are real scientists who are really on board with this and really want to make it happen. Launching humans and objects into space on rockets is extremely expensive. For example, NASA has estimated its 4 Artemis moon missions will cost $4.1 billion per launch. The reason is something called the rocket equation. It takes a lot of fuel to get to space, but the fuel is heavy, which increases the amount of fuel you need. And so you see the kind of vicious cycle here, Johnson said. With a space elevator, you don't need rockets or fuel. According to some designs, space elevators would shuttle cargo to orbit on electromagnetic vehicles called climbers. These climbers could be remotely powered, like through solar power or microwaves, eliminating the need for onboard fuel. In his report for the Obayashi Corporation, Ishikawa wrote that his type of space elevator could help drop the cost of moving goods to space to $57 per pound. I had to read that carefully. Other estimates for space elevators in general have put the price at $227 per pound, to $227 per pound. Struth. Even SpaceX's Falcon 9, which is around $1,227 per pound, is one of the cheaper rockets to launch and is still about 5 times as expensive as the higher cost estimates for the space elevators. There are other benefits besides cost too. There's no danger of a rocket exploding. And the climbers would be zero-emission vehicles, Johnson said. At a relatively leisurely pace of 124 miles per hour, the Obayashi Corporation's climbers would travel slower than rockets with fewer vibrations, which is good for sensitive equipment. Ishikawa said that the Obayashi Corporation sees a space elevator as a new kind of public works project that would benefit all of humankind. Right. Just checking how long this article goes for. They say here that there's not enough steel on Earth to make a space elevator. Right now, one of the biggest obstacles to building a space elevator is what to make the tether or tube from. To withstand the tremendous tension it would be under, the tube would have to be very thick if it were made out of typical materials like steel. However, if you try to build it out of steel, you would need more steel than exists on Earth, Johnson said. So, of course, the other solution is a nanotube. A nanotube is a rolled-up layer of graphite, the materials that are used in pencils. It is much lighter and is less likely to break under tension compared to steel, so the space elevator could be much smaller, Johnson said. But there's a catch. While nanotubes are very strong, they are also tiny, a billionth of a metre in diameter, and researchers haven't made them very lengthy. The longest is only about 2 feet. So to be properly balanced while still reaching a geosynchronous orbit where objects stay in sync with the Earth's rotation, the tether would need to be at least 22,000 miles long. So we're not there yet, Johnson said, with the nanotube length, but that doesn't mean that it's impossible. So anyway, the article goes on for a little bit longer there, but if you want to read this article completely, it's on sciencealert.com. Go to www.sciencealert, all one word, sciencealert.com. Japanese company plans to build a tower into space by 2050. Well, it'll be interesting to see if that ever occurs. All right, let's jump into spaceweather.com. All right. The disk of the sun is currently looking like this. The solar wind is currently at 426.3 kilometers a second at a density of 2.84 protons per cubic centimeter. The current sunspot number is 149, while the the current radio flux, solar flux unit is 191. The KP index is 2.67, considered quiet. The 24-hour max KP figure is also considered 2.67, which is also considered quiet. The highest sunspot number in 22 years. The average sunspot number for May 2024 was 172. and it's considered the highest value in 22 years. So far, June is even higher at 200. If this continues for the rest of the month, June could log the highest sunspot count since December 2001. Yes, so revealing the peak of or potent of solar cycle 23. Right. Having said all that, the current picture of the aurora over the South Pole is this one here. So there's a little bit of auroral activity. If you're in Tasmania, you would probably see a small amount of glow. And they've got a little article here. A nova will explode this summer, probably, in brackets. They've got an artist's impression here of this supernova. There we go. All right. Very quickly. The night sky is about to get a new star. Sometime this summer, astronomers believe, a nova will explode in the constellation of Corona Borealis, or the Northern Crown. The exploding star will be bright enough to see with naked eye, even from light-polluted cities. It's a once-in-a-lifetime event, says Reba Hansel of NASA's Goddard Space Flight Center. He says, "I believe it will create a lot of new astronomers out there." T Coronae Borealis, TCRB, is a binary system 3,000 light years from Earth. It consists of a white dwarf orbiting an ancient red giant. Hydrogen from the red giant is being pulled down into the surface of the white dwarf, accumulating toward a critical mass. Eventually, it will trigger a thermonuclear explosion. The first time TCRB exploded was in 1946. About a year before that blast, the system suddenly dimmed, a pattern astronomers called the pre-eruption dip. In 2023, TCRB dipped again, heralding a new eruption. If the 1946 pattern repeats itself, the nova should occur between now and September 2024. The outburst will be brief. Once it erupts, the nova will be visible to the naked eye for a little less than a week. But Hansel is confident it will be quite a sight to see. The expected magnitude is between +2 and +3, similar to stars in the Big Dipper. They're referring to Northern Hemisphere, so I'm not 100% certain whether we'll be able to see this in the Southern Hemisphere. I don't think we will. I think this is going to be a predominantly a Northern Hemisphere object. So stay tuned anyway, and we'll let you know what transpires. Having said all that, as of June 7, let me just bring my camera back. Oh, where's my camera? There it is. As of June 7 this year, there is 2,349 potentially hazardous asteroids. Potentially hazardous asteroids are space rocks larger than approximately 100 meters that can come closer to Earth than 0.05 AU, but none of the known PHAs is on a collision course with our planet, although astronomers are finding new ones all the time. So it says. Alright, so that's spaceweather.com in a nutshell. And I think we'll leave it there for the time being. Alright, well, I hope there was something of interest tonight out of all those articles. Everything from the ASV's Juniors section to redoing Sky Notes, the Lunar Day, SpaceX's Starship success, why the stars don't shine on the moon with a proper camera, and of course the telescope in Hawaii and the Japanese space elevator. So there it is. And I think we're still streaming. Yep, the modem has not fallen over since the last time, which is good. All right. On that note, we shall now turn towards HF, and we'll take a quick listen on 3541 kilohertz for any stations wishing to check in. So this is VK3 EKH listening on 3541.
VK3 Golf Lima. VK5 Whiskey Alpha. VK3 VK3 This is VK3 Kilo Italy Sierra.
All right. There's a couple of stations that doubled there, but I think I got yours. VK3GL, VK5 Whiskey Alpha, VK3SBX, VK3TJS, VK3KIS. Was there any other stations there?
VK3 BKO. Oh yeah, there it is. VK3 AOB.
All right. Acknowledging VK3 BKO and VK3 AOB. Anybody else? Alrighty then. To the top of the list. G'day, Graham. VK3 Golf Lima, VK3 EKH. Oh yeah, got you, Steve.
Alright, I will go. VK3 EKH, VK3GL. Yeah, very good there, Clint. Thanks very much for the broadcast this evening. All very good and all noted. VK3 you've got signal here on 80 metres. Started off a little bit down, and also some quite interesting fast QSB between Bunyip and Narre Warren South. But it settled down as the broadcast went on. Good to see that you've got the YouTube stream sorted out as well, and that it stayed active for the remainder of your broadcast tonight. Some good articles there. Enjoyed what you had to say. In particular, some of the space weather information that you shared towards the end of the broadcast. I note that you said that the KP index was supposed to be quiet. I had a quick look online, and it's actually considered to be mildly active. There's a bit of there's a fair slice of green and some yellow down on the South Pole at the moment. So who knows what that's going to eventuate into, if at all. But I guess as a result of what happened a couple of weeks ago, or 3 weeks ago, people are sort of taking a bit of an interest in this and keep a bit of an eye on predictions for additional aurora activity. All right, well, look, thanks very much for the broadcast. Heard everyone else check in particular Brett. AOB, gee, what a fat signal that was tonight when he called in. It was about 40 over 9. Very strong signal this evening from your location there, Brett. All right, back to you there, Clint. Thanks very much for the cast. I may catch you towards the tail end of the check-ins if time permits. VK3EKH, VK3GL.
Yeah, no worries, Greg. VK3GL, VK3EKH returning, and yes, you are right. I've just taken a quick snapshot of the current auroral glow over Antarctica, and you are quite right. That's the current image right now. The image that I showed was taken just before I went to air, so this is the current image, and there is a slight yellowy glow to it. So that's suggesting that we've got a 50% chance of seeing some aurora low on the horizon, particularly if you're in Tasmania. So yes, and if I refresh spaceweather.com, where are we? Just double check what have I done to it? Oh, that's right. I had to do that, didn't I? Let's see, just refresh it. Yep, okay. Well, yeah, they haven't updated their page. This is still reflecting probably the last 24 hours. So yes, you're right. Oh no, you're quite right. Yes, you're quite right, Mr. Lewis. It's amazing in the space of an hour how that changes. The KP index has definitely gone up to 3.33. But it's still considered quiet though. The terminology is still quiet, but the figure has gone to 3.3. So yeah, definitely a little bit on the increase there though. That's for sure. Thank you, Graham. Most appreciated. And yes, I'm only running low power tonight. It's only about 20 watts. So no, it's not 20 watts. It's just 100 watts. Just the standard output from this transceiver. So even that was enough to trip the motor once tonight. Anyway, thanks, Graham. Good on you, mate. Thanks for calling in. Dallas, VK5 Whiskey Alpha. I hope the signal's been good over there in South Australia tonight. And I'm interested in reports on the HD TV signal on Discord too, folks. VK5 Whiskey Alpha, VK3 EKH.
Live stream last night of the Starship, and the next step, the data they got back from the video, live stream video of a re-entry object. That's got to be, I thought, one of the most remarkable things I've seen. And I've got the images now to do the modifications and stuff to make it robust. But imagine the software got through all that and landed it. That's got to be, I was just astounded by what happened with that last night, and to actually just see the actual plasma forming and then having enough blow through to melt the stainless steel, and then still have the ears still able to flap in control and do the flip landing on the other side of the earth. Out past Western Australia there. I was just astounded by it. Anyway, thanks, Clint. It was really good, and I watched a fair bit of it on YouTube too. That went really well. Thanks again. VK5.
Yeah, good on you, Dallas. VK5 Whiskey Alpha, VK3 EKH returning. Yeah, I happened to watch that too. I was in bed and I should have been asleep, but there I am, mobile phone, and at 2 o'clock in the morning, and I'm watching this all happen in real time, or close to it. But I was absolutely mesmerised by the video coming back from the. They've got cameras just about everywhere, and yes, seeing the way this whole launch unfolded, and it was just a little unfortunate that there was a certain amount of debris falling onto the camera lens, or the cover over the lens of the camera was getting slowly but surely covered with debris, and it was blocking the vision to things. But still, it was really fascinating to see how this thing was working. They've got a long way to go though before they can make this rocket safe. I don't know, it's a huge damn thing. So to put astronauts on this thing, it's it's just risky. Anyway, watch this space, as they say. So it'd be interesting to see what transpires in the near future with this business. But obviously, Elon Musk has a lot of money to burn, literally. Thanks, Dallas. We'll be back to full power next week, hopefully. Hopefully. All right, Steve, VK3SBX. I think you've sent me an email as well. Yes. Yeah, okay. I'll leave that till next week then, because I would have liked to have mentioned that. So I'll leave that little report for next week. But thanks for doing that. That's great. That's a good story, isn't it? Actually. All right. VK3SBX, VK3EKH.
VK3EKH is VK3SBX. Yeah, I nearly fell over when I bought that paper this morning in Malden. I know her quite well, actually. Been around her place a few times and vice versa, because we're only about, 5k apart. Yeah, there was a lot of interesting stuff today. I'm watching the Discord and the YouTube video at the same time, Clint, so I can see your response in real time. I'm listening on the radio, of course, but it's almost like just bad lip sync, but it's pretty good, yeah. Yeah, so it's improved a bit, actually. It was a little bit blurry to start with, and now it's about on par with the YouTube video. So it comes and goes a bit, and I think it depends upon various bandwidth constraints in various places. So it's interesting. Anyway, there's lots of interesting things. I actually set up the telescope. I'm doing some imaging tonight for the first time in a whole while. So that's something. I've changed the program I use for the automation. So I wanted to try that out. What else? Those people who don't understand about exposures and the stars not being visible, they probably went to the same school as Donald Trump, who doesn't believe magnets work underwater. So God knows. Now I got to talk about this space elevator. I've got to talk about that. I have read the books by Tim Stanley Robinson, and although the Japanese maintain that it'll be much safer, just in case a spacecraft falls out of the sky, if you read the books, you found the space elevator on Mars failed rather badly, and the tether wrapped itself around the planet several times and caused thousands of deaths and just incalculable damage. So I think you should bear that in mind as well. The concept starts about 1895, so it's not new. It was popularised by Arthur C. Clarke, who addressed the U.S. Parliament, or what do they call it, about it as well once. And he wrote a book called The Fountains of Paradise, which also has a space elevator in it. But the trouble is you have to make it out of unobtainium. I know that you mentioned, someone said you'd have to be 22,000 miles long. I think that's wrong, because that's only geostationary. It's got to be way past geostationary. The counterweight has got to tension the cable. It's no good just putting the end of it in a geostationary orbit. That'll just fall right down. So I read one report here said it needs to be about 144,000 kilometres long. Considering we can only make a tether 2 foot long at the moment, I reckon that's going to require a little bit of extra innovation, to put it mildly. So good luck with that. I don't think we're going to see that anytime soon. All right. I just couldn't resist that. It was just so interesting and hilarious. Thanks, Clint. VK3EKH is VK3SPX.
Yeah, I tend to agree. VK3SPX, VK3EKH. It's I think it's a technology at the moment that looks good on paper, but I think being able to generate or create the materials for such a venture, it really is just science fiction at the moment, and it only really works in science fiction. I can't begin to imagine how they could build a structure that would just go up through the atmosphere of the Earth. You're talking about hundreds of kilometres to get out into space. A structure like that would just fall over. It would just topple. So, I have no idea how they would do it. So yeah, it works. It works in the science fiction perfectly well, but I think in reality, it's I don't really see it ever happening. Not for a while at least. So yeah, it'd be interesting to see what they come up with over the next few years if they decide to actually seriously continue such a thing. But yes, those three books, Mars, what is it? There was Mars, Red Mars, Red Mars, Blue Mars, Green Mars, I think they were called. And there was one book on just called Mars. I had great fun reading those a long time ago. Those books were published. Anyway, thanks, Steve, and thanks for sending the email too. Jack, VK3TJS in Shepparton, VK3EKH.
Yeah, VK3KH and the group. This is VK3TJS. Good evening to you, Glenn, and good evening to everyone that joined the broadcast and was listening to it. Certainly quite interesting, and with varying signal strength from you, from about 59 to 59 plus 20 plus. So yeah, but you said you're running 100 watts, so that's quite okay. And yeah, very, very high noise on the bands here in Shepparton at the moment, probably everywhere. I think more the storms, atmospheric, whatever. And that's how it is. Long weekend ahead of us, so I hope everyone enjoys it and makes the most of it, and hope the weather stays good. My daughter, she's lives in London, she's on holidays at the moment in Europe, but she brought in a telescope that she bought, and she never used it, and she said she's not smart enough to work it out. But yeah, anyway, I've got this telescope at home, and I've never used one. Maybe one day on a good night I'll read the instructions and set it on, and it'll be quite interesting to see what's out there, and the close-ups of moon and various other things. That'd be quite good. I mean, I've seen pictures on the internet, but nothing through a telescope. So that's my plan for the next several weeks, I guess, whenever the weather is good and I can with some time. So again, thanks for the broadcast, and hope you have a good weekend. Enjoy it. VK3KH on the group. This is VK3TJS.
Yeah, thanks, Jack. VK3TJS, VK3EKH. Good signal from you tonight too, Jack. You're hovering around that 20/9 mark quite solidly. So very good signal indeed. So I'm glad that the propagation on the band is okay tonight, given that I am running the lower power. But thanks for the report. And yes, getting used to a telescope is a little bit of a skill. It's a little bit of trial and error. And hopefully she won't be too disappointed if she can't quite get the results that she expects straight away. I mean, if you can, I'm not sure what type of telescope it is, but if the telescope can have a camera fitted, I think that's where the other interest comes from with the optical astronomy. You can only look through a telescope so many times and start thinking, well, every star looks the same. So, I think with optical astronomy, where it really shines, pardon the pun, is where you can attach a camera to it and take photographs. And if you've got a good mobile phone, you can actually get adapters that will hold a mobile phone in place over the eyepiece of a camera, and it'll work quite well. You can do some interesting things that way, rather than spending a lot of money on dedicated cameras. But certainly, if somebody was to say to me, what's a good way of getting into doing optical astronomy, I would usually indicate a pair of binoculars would be the best starting point. I know holding a pair of binoculars is a bit of a difficult thing. Your arms tire quickly and you're moving all over the place. But at least if you haven't really looked through a telescope at this stage, a pair of binoculars is a good way to start. looking at the sky and looking at the moon, and then if that still grabs your interest, then you can think about getting a reasonable telescope. It all starts to get a little bit on the expense side. But the Kmart specials and the Target specials with those sorts of telescopes, and the cheapies that you see at National Geographic, just stay away from them. Anyway, that's another story for another time. Anyway, thanks, Jack. Good to hear, mate. Andrew, VK3KIS, VK3EKH.
Good evening to you and all on the group. Hope everyone's keeping warm. Interesting stuff in space this week. I've just been amazed at how much news or how much activity there's been in space. The Chinese landed on the far side of the moon to collect samples. And they already in orbit with the samples to return to Earth. I think they're going to take another fortnight to get back here. And of course, we also got the SpaceX launch, and earlier in the week was the Starline alert that finally got off the ground, and no computer glitches this time, and no explosions. Good stuff. And the doctor at the International Space Station today. So a lot of space going on, and so on. But the only piece of advice I can give was setting up a telescope. You don't do it at night. Get used to setting it up during the day, and be prepared to be frustrated and accept that you won't get it right all the time. Just see if you can get the telescope set up with the focus and get the finder scope aligned with the main telescope and so on. That will save you a lot of frustration. And as far as having a camera is concerned, I've had to go that way. I can't stand up and look through the eyepiece. I've got to do it in a seated position. So I've been doing that. And once you get into the market of cameras, you expect to be surprised at the prices. And no crying on air, shall we say. Anyway, I'll say 73, thanks for doing this. Again, VK3EKH, VK3KIS. Over.
Yes, thanks, Andrew. VK3KIS, good to hear. VK3EKH. Yeah, look, you're quite right. There'll be a certain amount of disappointment, and that's where if you've got a little bit of a love for astronomy and wanting to explore the universe through a telescope, you just got to persevere, and that's why I think that if you definitely have an interest in astronomy and want to kick off on the right foot from the word go. Normally, we always suggest that a Dobsonian telescope is the thing to look for. An 8-inch Dobsonian, because they're easy to manoeuvre. They're not terribly awkward to pick up and move around. But because of the very nature of the Dobsonian mount, it's easy to move to any part of the sky very, very quickly, and of course you can fit any kind of eyepiece in there to be able to bring the image to your eye. So a Dobsonian, an 8-inch Dobsonian telescope is a good way to start, and they're not terribly expensive. I mean they're probably under $1,000, I suppose. It depends on where you buy them, but good telescope good practical telescope for studying the sky. And of course, then if you're still interested, if it still grabs your interest, then you can start thinking about computer-controlled telescopes, which is where I'm heading to for doing astrophotography. So we're still working on that. Anyway, okay. Thanks, Andrew. Across to Brendan, VK3BKO, VK3EKH, a local lad.
VK3EKH and the group VK3BKO. Well, g'day, Clint. Sorry I missed last week. I really wanted to listen to you, but I had other things. Unfortunately, had an accident last week and damaged my coccyx. That's the tailbone. And so I've been off work all week. So I've had a lot of free time. I've been glued to NASA TV, mate, watching Sundowner. Sunliner, I should say. I keep mixing that up. Sunliner, and I watched the launch and the docking early this morning, and fascinating stuff, and all the little packets of video they put through as well on NASA TV. So with all this free time in my hands, I've been doing a lot of science fact as opposed to science fiction. We talked about science fiction, anything star, mate. Star Wars, Star Trek, Stargate, yeah. But I really enjoyed today, and thanks very much for the podcast. I will look into Discord. That looks like a great way to link up the radio and the video feed more closely. So thank you for that. And and thanks also for the link on Heavens Above. I'm having trouble locating the ISS on my old Celestron. I've been tracking the ISS on the YouTube feed, and so when I see it coming over close to me on the map, that is the southeast corner of Australia, I basically try to orient my telescope in that direction, and I just haven't had any success. But that Heavens Above, that might give me a more closer bearing. So thank you for that. As for the space tower, well, mate, I don't know about that. I think that's not entirely plausible. Even if they did scrounge up enough metal, keeping it in the correct rotation with the Earth, I mean, my goodness, one stuff up and where would we be? But anyway. And okay, on the link on the tip for 8-inch Doxonian, I might look into that myself. But thanks very much again for the podcast, mate, and 73 to you from my station, VK3EKH, and the group VK3BKO.
No worries, Brennan. VK3BKO, VK3EKH returning, VK3CSJ on the microphone. Yes, not a problem. No, astronomy. Sorry, heavensabove.com. Heavensabove.com. You'll find all anything that's up there in orbit around the Earth and any celestial object. It'll help you locate them once you put your location in, and particularly the International Space Station. It gives you a complete list of when that International Space Station will be visible here in Melbourne, or anywhere for that matter. So it's a good site. And star maps. It generates star maps as well. It's a great site. It's been running for quite a while now too. Telescopes. There's a couple of shops in Melbourne. Just can't think of them at the moment. There are a couple of dedicated telescope shops that are still around. So it's shouldn't be too hard to find. What's the other thing? Oh yeah, and on Discord. Yeah, like I say, Discord. Just go to the website and register on Discord. It's there's there's no subscription as in paying or anything like that. It's a free thing, and as somebody here on chat window who said it was good. I think it was David. David said that he was a fan of Discord. So there it is. Just looking at the folks on Discord here. So David VK3 KDM, Steve SPX, Kim VK5 of USC. G'day Kim. Daz up there in Brisbane, who reports that the signal is not as strong up there at the moment, just above the noise. Yep. Well, next week I'll be back to, hopefully I'll be back to the normal 400. Yeah, so there it is, and I can see just a little insert of because I'm transmitting on Discord, I can see the insert of my vision on the far right of the screen there, so I know I'm broadcasting. Okay. All right, next on the list. Brett, VK3 AOB, VK3 EKH. Have a say there, Brett.
I'm having a say. How are you going, Clint? Good evening all. And yes, it was good. I set up the big screen TV, and I've got a deconnector from the computer to the side of so it's a big screen. Your illustrious tones and face were on the screen for a while, and then you looked around at the camera, and it looks like you're pulling a face. It just froze, and then I had nothing after that. It just the TV went black after a while, so I put it all off. But that's on the YouTube channel. Anyway, there you go. Good broadcast as usual, and interesting topics. You did dent my ego a little bit. I'm the proud owner of an Australian Geographic 150mm reflector that's in there, which I haven't even used. So telescopes are not that easy to come by. Good ones anyway. I did go to York Optical 40 years ago, back in late 70s, around 1980, 81 or 2, up in Flinders Street, and it was a big Meade telescope. It's a beauty. I forget what they were now.
Very expensive as well.
Or something at the time. And I looked at the police academy through the maximum magnification eyepiece, and I was looking at approximately a 10-foot square section of brick wall. I thought, wow, wouldn't I love to have this, but couldn't afford it, never bought it. Anyway, you get that. All right, waiting for the heater to die. I can have a shower and get into bed. Good broadcast, so maybe we'll do it all again next week. VK3 EKH, and the big group, VK3 AOB.
Yeah, good on you, Brett. VK3 AOB, VK3 EKH, and there's plenty of fan noise there in the background too. That's very easy to hear. But yeah, thanks for coming on today and the report. Look, the video's been there. As soon as I saw the modem fall over, I just waited until it was back online again. So YouTube is been there, as it has the Discord channel. So and of course the RTV hasn't fallen over once. It's been pretty good. But anyway, I'm going to be starting to use the Discord channel quite a bit. It took a little bit of fiddling around. The audio side of it was the thing that I was having difficulty trying to work out. But fortunately, Richard VK3 VRS managed to nut that one out earlier in the week, and we got that sorted out. But I've still got I still can't run audio from the computer through the mixer to HF at the moment. I normally can, but I've got to sit down there with a piece of paper and map this out so we can get it fixed up for next week. For all I know, the Space Weather Woman could be there with an article I could have run tonight. I don't know. I haven't checked her website, but anyway, thanks, Brett. And look, the National Geographic telescope, it's a toy telescope. Yeah, look, the problem with those telescopes is that they've got a small aperture, and hence the tripod, if there is a tripod, there should be a tripod, isn't really stable. Wouldn't be very stable. So in looking for objects like, let's say you want to look at Jupiter, you'd probably resolve Jupiter as a small disk, and you'd be able to see the main moons as bright little specks. But within a few minutes, it would be out of sight. You'd be forever correcting the telescope to keep Jupiter in view. But I mean, for quick viewing, it's not a problem, I suppose. You'd be able to see Jupiter as a small disk. You might not be able to make out colour bands, but at least you can say, oh, there's Jupiter, there's the main 4 moons of Jupiter. Saturn, you'd be probably able to make out the rings of Saturn, but nothing in any great detail. But at least you'd say that's Saturn. You'd be able to recognise it. And close-ups of the moon, for sure. Even globular clusters would probably be visible. Should be. But again, like I say, the stability of the telescope and on the tripod is the thing, and trying to keep an image in view long enough to be able to study it. So yeah, they're a little bit limiting, but I think for a first time, to explore the heavens and get a bit of a feel for it, it's the idea is a stepping stone onto bigger and better things. But as you say, it is expensive. Telescopes aren't cheap, and if you really, really, really want to do astronomy, optical astronomy, you've just got to budget for it. So anyway, all right, thanks, Brett. Steve, Mr. HK, if you're still awake, VK3 Hotel Kilo, VK3 EKH.
1, 2, 3. This is not working very well for some reason. Mainly, hang on. There we are. That helps if I'm on 80 metres rather than 40. Anyway, good evening, Brett. Yeah, you need a shower. I'll explain it from here, old son. Get in the shower. Plenty, old boy. Yeah, nice broadcast. As for Discord, or whatever it's called, it's a total waste of time as far as I'm concerned. It's impossible to get onto. When you finally get onto, you're frustrated to death just about. Anyway, you've probably seen my comment, which I emailed to you. I've given it away. Just it's a non-event. I'm quite happy with the YouTube thing. Yeah, it falls over from time to time, but I don't have to look at you all the time. I can listen to you direct on 80 metres. Now, one thing, two things. I'm very disappointed in the broadcast. No Tamatha, mate. And the other thing, not one mention of the Sati. I know that they're not going to be here for 400 years, but I thought you would have had some comment on them. Very disappointing. You have to pick your game up, old boy. Anyway, loud and clear, you're hitting 25 over 9 here in Ferntree Gully, and that's strong enough for anybody. Back to you, VK3 EKH. This is VK3 HK.
Yeah, okay, so what was the other thing that I didn't mention or didn't have?
The Sati. There was no mention of the Sati. 3-body problem.
Oh, okay. Was I going to mention that? I'm not sure if it was on my my list to talk about, but I can make it, I think, for next week. Yeah. All right. Look, we'll consider it for a possible mention next week. Three body program. It's a 8-part, I think, 8-part series on. Is it Netflix? Yeah, I can review it. I'll make a review, and maybe I should also watch the last 2 episodes to catch up with the way it ends. I saw you. I'm not sure if it was an email now or a comment you made. I think it was a comment you made on the Coffee Break Net on Wednesday or Thursday about it. Somewhere I read something a comment you made. So yeah, and yes, I just quickly put up Timothy's caption on YouTube, which you'll probably see in a minute. I don't know. I can quickly check to see if she has got a a report. There's got so many things open here. Right, let me see. Have a quick look at her YouTube channel, and I'll see if there is anything that's current. 18 hours ago. Well, blow me down. She does actually have a report. It's 18 hours ago. She published a 12-minute report. I should have checked it, but the problem is, though, I can't really run it at the moment because I don't have audio patched through successfully, so nothing would have gone out onto HF. But if you type in Space Weather Woman on YouTube, type in Space Weather Woman in your favourite YouTube search engine, you'll find Dr. Timothy Scove's website. And if you go down a little bit, you'll see her report. It's called "The Sun Pranks Us with a Halo, Space Weather," something or other. So it goes for 12 minutes, and it was published 18 hours ago, and she's already had 26,000 views of that particular report. I'll just run it for a sec here. I'll see where her predictions fall. So it goes to Monday. Her predictions go as far as Monday, so I'll probably run this. Excuse me. I'll probably run this on Sunday. Oh, I'm losing my voice. I'll probably run this on Sunday morning. Yeah, before most likely before the WI broadcast. I'll feature it there. Anyway, all right, that's interesting. I didn't know that she was there. All right, not to worry. I'll pause it just there, I think. Okay, Steve, not a problem. What I'll do, if I haven't already, but what I'll do is I'll send you a link, a Discord link, that will take you straight to the chat room for the ASV thing where you were just last week, in fact. That's all you really need. If you are registered on Discord, that's one thing. If I send you this link, and I'm sure I've already sent you this link, it'll take you right through into the chat room, and where the video, the HD stream is, it's just a matter of locating it. Yeah. Anyway, all right. But if you don't mind the delay, the YouTube is just as good. Yeah. All right. Enough of that. All right. I may be on tomorrow morning on the Coffee Break Net at some stage. It depends on what I get up to. All right. Is there any other stations wishing to report on tonight's cast? VK3 EKH listening? No. All right. Okay. Thanks everybody for calling in. A special hello to Peter, VK3XQ. He's often listening to the transmissions here, as he's pointed out. So thanks, Peter, for listening, and your emails too that you've sent this week. Again, it's most fascinating indeed. The AI technology there, it's just absolutely gobsmacked at what can be done with quality artificial intelligence, if you can say that. Anyway, thanks, Peter, and thanks for listening in too. Thanks, Graham, Dallas, Steve, Jack, Andrew, Brendan, Britt, and Steve for calling in tonight. Everybody who's on Discord there, Dave, our resident Mount Burnett astronomer, and Kim VK5 FUSE, and Daz, thanks for calling in, guys. And the email we have, just the usuals. So thank you very much, Lee. And hopefully we'll be back to full power next week, and also being able to stream stuff, well, not stream, but to pass audio through to HF. We've got to get that sorted out. So this is VK3 EKH on behalf of the Astronomical Society of Victoria. More information about the ASV can be found at www.asv.org.au. And we'll see you all next week. Have a nice long weekend, everybody. I know the weather's going south halfway through the weekend, but stay warm, and we'll see you all next Friday. So take care and look after yourselves. This is VK3 Echo Kilo Hotel. Clear and closing down, and have a nice weekend, chaps. See you then. VK3 EKH clear.
Job well done there, Clint. Your signal report, you were varying from 5x9 plus 15 at the worst to 5x9 plus 35, but you're floating around 25 to 30 all night, so getting out quite well. All right, have a good weekend, and good night all. VK3 AOB going that way.
Thanks, Brett. Good on you, mate. On that note, you can hear HF, that's 80 metres directly patched through. No, it's not. Alright, I think I'll go and leave the system. I'm about to fall apart, I think. Sure, can I do it? Can I do it? No, I can't. Yes, I can. No, I can't. I thought I had my little closing down thing, but I don't have it here. Doesn't matter. Next week. Alright, you've been listening to VK3 EKH, Clint Jeffrey, VK3CSJ with another Friday night broadcast. Everybody who's been watching the ATV side of it, thank you for watching, and I'll be back again Sunday morning. There'll be a WI broadcast, the video adaptation broadcast at 9 o'clock on 1825 kilohertz, and I'll be running the video on Discord. So if you're listening to me on 1825 kilohertz AM, you can follow the video on Discord. I'm interested to really explore that little thing. So yeah, and then of course an hour later I'll be doing it all through this repeater. So all very exciting stuff, isn't it? And I'll run Tamitha's report as well. In fact, I might even, maybe I can do that now. Yeah, let me just download it. Why not? Yeah, I can do that. Let me see, let me download it first of all. Let me go back to Tamitha. There she is in all her glory. Let me just refresh the page. And nope, I'm going to have to copy and paste the link and then go to my favorite downloading program, YouTube downloader, and copy and paste the link into there and download. Oh, go away. Some unusual thing happening here. There we are. Okay, got it. Download. It's 42 47.2 megabytes in size. So it's now downloaded, which will be sitting in that file. So we open that, downloads, there it is. Oh, I can probably run it from there, don't have to worry about it. Okay, stand by while I drop it into vMix. A lot of key clicking going on here, mouse clicking. Downloads, there it is. Alright, stand by for the Space Weather Woman. Let me bring up her special neat little caption that she's got, and I shall load her video up just like that. And here it is, 10th of the Scove, 12 minutes of space weather and what's happening this weekend. You're tuned to ASV Radio, VK3EKH. Here is 10th of that for you, Steve, if you're watching still on YouTube.
Our sun pranks us with a far-sighted eruption, and a gorgeous non-Earth directed solar storm launch shows us that region 3697 isn't the only game in town. Those stories and more in this week's Spotlight. Our sun is being a bit of a trickster this week. As we take a look at our Earth-facing disk, we can see region 3697 up to its old tricks. It has been a big flare player. In fact, on June 1st, it lights off a big X-class flare. You can see it right here. Bam! Then, almost immediately afterwards, we see this gorgeous halo structure in coronagraphs, and it leads a lot of people to think that we've got this Earth-directed solar storm coming from region 3697, and it's a repeat of what we had early in May. But not so fast. As we take a closer look at what happened, we have Halo CME, who's a member of the SDO AIA team, and he did some difference imagery analysis to really kind of reveal some very important features. Number one, we have that big solar flare right there, and you can see it like that. Now, normally what we would see if there was a big solar storm being launched is a lot of dark regions all around this with a big blast wave that propagates out all along this disk. You can see the outline of the sun here in black. Can you see it all the way around? Now, there's not a lot of dimming, so this isn't very eruptive. And then look to the southwest or southeast over here. Watch this. Do you see that big shock wave? Well, that actually was coming from behind the limb of the sun. It wasn't coming from this region at all. In fact, after that shock wave disappears, now this region begins to unfold, and you can see it. You can now see kind of a shock wave kind of blasting off this way that's going to take material to the south of it, and you can see this thing kind of unfolding like a flower to the north as well. Watch how long it continues to unfold, and it begins to get other regions in here involved in this whole eruption. So this was a very different kind of eruption than what we originally thought. As we look at it from that perspective, now looking at the blast in slow motion, we can see there's the big X-class flare. Now you don't see a big wave propagating this way, but you do start seeing some dimming regions unfold in here. You can see it unfold this way, and then you can also start seeing it ripple up a little bit. In fact, look at this. Before too long, you're seeing region 3698 and region 3705 get involved. See the dimming in here? So that gives us a totally different perspective on what's happening. We see that first halo, that is actually associated with that shock wave from the far side of the sun. So this structure is actually a solar storm that's going away from Earth, not towards Earth. Then we get the second blast. That's this part here, and that's from most of the stuff that's going to the southeast of Earth. And then remember, we've got all the stuff that's kind of propagating north, and that actually could be this third set of structures up in here and even a little bit down in here. So we may have had actually 3 separate solar storms fire with only one of them. The last little bit being what grazed Earth here over the last day or so, but no big solar storm. Now, if we needed any more confirmation, we can also take a look at the Solar Orbiter STIX instrument, because that instrument actually has the light curves that show us how big the solar flare was that happened on the sun's far side. And according to the STIX instrument, this was an M2.8 class flare that caused that big shock wave on the sun's far side and that big beautiful halo that was moving away from us, not towards us. And if we take a look at the STIX indicators for where the solar flare originated, it sure looks like it's going to be somewhere close to region 3683 or maybe even 3674. Kind of hard to tell because it's just an estimate, but we'll talk more about those regions in a minute. Meanwhile, as we return back to our Earth-facing disk, take a look at this big filament. We thought this thing was going to erupt, but it sure hasn't. It just kind of toyed with us. Once again, the sun is just pranking us. And so then we took a look at the east limb of the sun, and you're really beginning to see some of these regions rotate into Earth view, and they've got a lot of structure up here high in the upper atmosphere. In fact, you see a little bit of things erupting, but take a look at this filament here over the last 24 hours. This region had a spectacular launch. As a matter of fact, I'm going to pause it right there and back it up just a smidge. You can even see this blast wave. Can you see this blast wave as it blasts off? Watch this thing. It's like a perfect, just textbook example of these big solar storms. In fact, when we take a look at it from Suvi's perspective, you can see even more material. Look at that gorgeous structure as it moves off. Now, this structure is not Earth directed, but what it does let us know is that filaments are also at play here. It's not just the big regions. So not only do we have to worry about region 3697, especially as it rotates to the west limb, but we still have all these filaments. This one is in the Earth strike zone, and we've got lots of stuff playing on the east limb, especially high up in the upper atmosphere like that, means it's very unstable. So as these regions rotate into Earth view, it looks like we're going to be still having big solar flares and also the potential for big solar storms. Now, as we switch to our sun's far side, we can no longer use stereo A imagery to look at the sun's far side because stereo A is looking at the same side of the sun as we are. So we have to switch to AIA and HMI imagery of about 2 weeks ago to get an idea of what kind of regions are lurking there. And as we put this into motion, you should immediately see regions 36, 83, 74, and 79. These were big players the last time they were in Earth view, and we know that region 3683 is the likely suspect in firing that big M-class flare and that big, beautiful, far-sighted halo eruption, so solar storms could be on the menu. In fact, as we pull up our JSOC HMI helioseismology far-sighted monitor, you can see what's in gray is on the front side and what's in gold is on the far side. And as these regions rotated onto the sun's far side from the last time we saw them, look at these dark regions. You can definitely tell they're surviving their far side passage now. In fact, region 3674 and 83 may even be merging a little bit, but they are could definitely be big flare players as they rotate back into Earth view, which will happen over the next couple days. You can also see region 36, 85, and 86. Those regions were big players last time. You can see how large those two regions were together, and they could definitely be giving us some more activity, even if these regions here fizzle out. So expect to see the potential for more big solar flares. The solar flux levels will rise, as well as the big flare possibilities that will stay up, and big solar storms could be back on the menu. And even if these regions fizzle out as they rotate into Earth view over the next couple days, in about a week, we have this set of regions as well. So it looks like we're going to have activity that's going to be here to stay. Switching to our moon, we are now passing through the new moon phase, with the new moon being on the 6th. And by the 11th, the moon will be about 25% illuminated. So you night sky watchers, if you want to catch those dim objects in the sky, now is your perfect chance. Now, switching to our solar storm conditions and aurora possibilities over the coming week, we are dealing with unsettled conditions right now. This is because we really just don't have a lot going on. We don't have any fast solar wind coming at us, and every solar storm that's been launched has not been launched towards Earth. So NOAA's giving us only about a 20% chance of minor storm conditions at high latitudes, and this will last over the next couple days. Things will then calm down even more, so we only have about a 25% chance. So So aurora photographers, it looks like you're just going to need to hang on a little bit longer because we don't have any solar storms in the works yet. And at mid-latitudes, well, the story is pretty much the same. We're expecting unsettled conditions with only about a 10% chance of activity. So this means that the conditions are going to remain mostly calm throughout the week. Of course, things could change very quickly if we get a solar storm launch. So take all of these long 5-day outlooks with a bit of a grain of salt. Now, switching to our solar flare and dayside radio blackout outlook over the coming week, we are still sitting well into the triple digits for solar flux, and this is because region 3697 is still rotating across the Earth-facing disk and will be for the next couple days. Plus, we have those new regions rotating into Earth view, so a solar flux is going to remain in the good propagation range. Of course, we have moderate noise on the bands right now, and that's because we have multiple big flare players in Earth view. NOAA's giving us about a 60% chance of M-class flares. That's at the R1 to R2 level radio blackout over the next few days, and even about a 20% chance of X-class flares, and that's mainly from region 3697. That will easily be over the next 3 days. Likely things will be calming down after that because we do have that region rotating to the sun's far side, and it's going to be hard to tell, but we definitely expect to have more big flare players on the menu rotating into Earth view even over the next week. And now switching to our radiation storm and polar aviation outlook over the coming week, we are all in the green when it comes to big radiation storms. We're sitting at the D1 normal range. This is at flight level 360 for you aviators. This is also the S0 quiet range for everyone else. But we do have about a 20% chance of a radiation storm at the S1 to S2 level easily over the next couple days. That might even pop up to 25% chance as region 3697 rotates to the sun's west limb. So you high-risk passengers, and this does include aircrew and frequent flyers, this forecast could change at any moment, so be sure to check those ICAO advisories regularly and take precaution in your flight plans. So the space weather this week is remaining mostly calm, but that could change at any moment. So you aurora photographers, make sure you keep your eyes on the forecast because we do have a lot of solar storms being launched. They're just not being launched at Earth at the moment. Now, you amateur radio operators and emergency responders, well, we are still dealing with region 3697 as it rotates to the sun's west limb. That does mean we still have a big chance for R1 to R2 level radio blackouts and even a skosh of a chance for R3 level radio blackouts. This will continue for the next couple days, although things may calm down just a little bit. However, we do have those new regions rotating into Earth view, and likely the R1 to R2 level radio blackouts will continue. So if you want to break from them on Earth's day side, well, check out the Earth's night side. We don't have any solar storms hitting, and so things should be pretty quiet there. And now you GPS users, well, you know, things aren't nearly as bad as what they were a couple weeks ago. Reception isn't super great on the day side, especially near dawn and near dusk because of those intermittent radio blackouts. But on Earth's night side, reception should be pretty top notch, except if you're at super low latitudes. So just kind of hang in there and hopefully things will continue to quiet down. I'm Tamitha Skov, the Space Weather Woman. Thank you for watching.
Well, there she is. Good on you, Tamitha. Thank you for updating us with the current solar report. Much appreciated. And she gets quite a lot of views on her YouTube channel, which is Space Weather Woman. And of course, she's a ham radio operator herself. Call sign is WX6 Space Weather Woman. WX6SWW, Tamitha Skov. Be good to work her on 20 metres one day, wouldn't it? Oh dear. Anyway, I shall now officially close down for this morning. I probably won't go to bed till 3 or 4 o'clock in the morning. I don't know, I just stay up. I'm absolutely tired right now. I could easily go to bed, but as soon as I finish here, I'll probably have another cup of coffee. Anyway, All right, let's set up my official close down sequence of events. Where is it? I just put it in. It's way down here. I've got all the stuff. Yeah, there we go. All right. This is how I remember television in the old days. Oh my God. What was it, Stu? You said something? It's not listening on 80 meters. All right. Anyway. All right. Get rid of that. Stand by for a little bit of history.
Thanks for telling that.
Yep, righto. Get into Discord, mate.
No, it doesn't like me. Keeps on asking me to do this and do that and identify which things are living and which aren't. No, go around and around and around. I can't get into the stupid thing. And when I do, it doesn't tell me anything anyway.
All right, I believe you. I know it's tricky. I'm still getting my head around it too. If it wasn't for a local amateur, Richard VK3 VRS, I'd be really lost. Anyway, so I don't blame you. All right, stand by for my special close down sequence.
Okay, so standing up and all ready to salute.
That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust, suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and triumph they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes. Settle? Not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known.